All right, one of the questions I've been asked about a few different times is number 15 on homework 2.2. This question gives us our function g of x as a piecewise defined function. So the first part of the function is this 1 plus sine of x if x is less than 0. So first thing we have to remind ourselves is what sine of x looks like. Now we know that sine of x traditionally goes through 0, 0, and then pi over 2, 1, and then pi 0, 3 pi over 2 negative 1, and 2 pi 0, and so on, following that pattern all the way across this path. Now, our function here is not sine of x. It's actually sine of x plus 1. So what we're going to do is we're going to take this graph, and all of these points are simply going to shift up 1 unit. So everything goes up 1 unit from where it is. We've got that vertical shift. So our graph here is this right here, right there. And then we're going to eliminate this sine of x1. Now, we also need to recognize that what we have here is a restricted domain, that we're only playing with this 1 plus sine of x when x is less than 0. So that is, we only have this graph over here. So we're going to go ahead and eliminate the right-hand side and make sure we only draw this on the left-hand side when we are less than 0. So right here. So this here corresponds with our purple curve. Then starting at 0 through pi, from here to here, we know that we are graphing cosine of x. Now we know cosine of 1 or cosine of 0 is 1. So we're going to graph right here at 0, 1. Sorry, I'm going to graph that right here. And then cosine of pi over 2 is 0. And cosine of pi is negative 1. But we're going to stop right there at that value. So we know we're right here. Then we know the next portion of the graph is for this greater than pi. And so we are going to figure out what is happening there. So we've got this section here, right here, greater than pi, and we're using sine now. So we know that sine of pi is 0, so we're here. And then sine of 3 pi over 2 is negative 1, and then sine of 2 pi is 0. So our graph is here. Now, one thing we do need to pay close attention to is the fact that this interval here is greater than and not equal to. So we need to make sure right here that we recognize there's an open circle, and down here there's a closed circle. Using this graph, we're able to find all of our limits, starting with this first one here. The limit of g of x, note this function here graphed is called g of x, as x approaches 0 from the left. So we're going to come right over here, approach 0, which is here, from the left, and we see that it is in fact 1. Follow that process to find the others.